Welcome back everyone to ResiCon 313. I'm Sherry. Okay, today we'll look at Chapter 10, which will have two videos covering three topics. The first topic is to define what is risk aversion, and then we will look at how a person's risk attitude or risk preference can be characterized as either risk averse or risk neutral or risk loving. And the second topic is to value uncertain deals. Okay. And the third topic is to value perfect information in uncertain situations. Okay. To value uncertain deals and to value perfect information, we'll need the information about a person's risk attitude, which is introduced as the first topic. Okay. Before we talk about the first topic, let's quickly review what we've learned in Chapter 9. Okay, so Chapter 9, we are introduced to Kim and we are tasked with solving the party problem for her. Okay, and we started this by asking Kim what are the alternatives of party locations, and then what are the possibilities of weather for Kim. After we figured out these two major components, we can apply the 5 rules of action of thought to help Kim choose a party location. And the choice is to have the party indoors since it has the highest preference probability. Here is just a roadmap of and also summary of the 5 rules of action of thought. First, in the probability rule, we need to assign probabilities to the two possibilities of weather. Okay, Kim assigned 0.4, 40% of the chance that it's going to be a sunny day, and 60% of the chance it's going to be a rainy day. And then we scratched this decision tree for Kim, where we put the choices as the first at the first node with the 3 branches. And then we put the uncertain weather as the second node, following each branch of the first node. Okay, these represent the uncertainties. The uncertainties come after the alternatives. That's because when Kim is about to make the decision, the weather is uncertain to her. Okay, and then in the second rule, the order rule, we ask Kim to order the 6 prospects from the best one to the worst one, and here is the rank order. She prefers outdoor party in the sunshine best, and this is her least preferred scenario or prospect. Outdoor party in the rain, and everything else falls between these two. In the third rule, we ask Kim to state her preference probabilities for each of the 6 prospects in terms of a binary deal between the best and worst scenario. Here, B refers to the best scenario or best prospect, which is the outdoor party in the sun, and these W's represent the worst prospect, which is the outdoor party in the rain. And then in the fourth rule, we ask Kim to substitute these binary deals with their equivalent prospect. Outdoor party in the sun is equivalent to this binary deal. That's why you see this binary deal over here. And outdoor party in the rain is equivalent to this binary deal, and then go on forward. Okay? And then as a second part of the substitution rule, Kim need to reduce compound deals into binary deals. Okay, this, what I'm circling with the laser point trace, is a compound deal. There are two uncertainties here. What we need to do is to simplify this compound deal into a simple binary deal. Okay, and after you do that, this is the simple deal reduced from this compound deal. Okay, and this is the simple deal reduced from this compound deal, and this is the simple deal reduced from this compound deal. Okay, this is the second part of the substitution rule. And lastly, we can use the choice rule to choose from the three locations by looking at the preference probabilities of each locations in these simplified binary deals. Outdoor option has a preference probability of 0.4, porch has a preference probability of 57%, indoors has a preference probability of 63%. Since indoors has the highest preference probability, we apply the choice rule to choose indoors as the most preferred, the best option in terms of the party location. We also looked at how we can simplify this substitution rule that requires a large tree and a lot of calculations. The way to do that is to simplify the substitution rule with e-values. Okay, so essentially, instead of putting these binary deals at the end to the position of each prospect, we only need to put the preference probability in this binary deal at the end. So if you can see here, instead of putting this binary deal, we can simply put 1 to indicate the preference probability of this outdoor party in the sun of this prospect. So over here. And then instead of putting this binary deal, or sort of instead of substitute this binary deal in for the outdoor party in the ring, we simply put 0 here, which is the preference probability. And now over here, instead of substituting in this binary deal that is equivalent to a porch party in the sun, we simply use the preference probability 0.95. Okay, as you can see here, 0.32, 0.57, 0.67. Okay, so this is just a simplification of this, complicated decision tree by putting the preference probabilities at the end rather than putting the binary deals. Okay, this is essentially to measure each prospect with their preference probabilities, because by choice rule, whatever prospect or whatever option that has the highest preference probability is the most preferred one. So these 6 numbers captures the essence of these 6 binary deals. Then what you can do next is to find the e-values of this binary deal, okay, by multiplying probability of this prospect times the preference probability of this prospect plus the probability of the other prospect times the preference probability of the other prospect. That's how you got this 0.4 over here. This is called the e-value of the preference probabilities. Okay, then you can also find the e-value of this uncertain deal, which is 0.4 times 0.95 plus 0.6 times 0.32. That gives us 0.57. And then you can do that for this one, which is 0.63. So by comparing these e-values of preference probabilities, it is clear that indoors is the best option. If you compare these e-values of preference probabilities with these binary deals from the substitution rule, you can see this 0.4 corresponds to the percentage of getting the best scenario. 0.57 is over here, the percentage of getting the best deal when she chooses porch. And then indoors 0.63 is right over here. When we do the choice rule, we're comparing these 3 probabilities, okay? And these 3 lower probabilities are essentially 1 minus the top probabilities. So in that sense, the lower probabilities are really not needed here. That's how we can simplify the substitution rule by using this preference probability as a measure of how Kim likes each prospect and then get the e-value of the preference probabilities to represent Kim's preference of the three options. Okay, so after this review, the major getaway is that preference probabilities are a special set of measure in terms of prospect values. Whichever prospect that has the highest preference probability is the most preferred prospect. Whichever prospect that has the lowest preference probability is the least preferred prospect. Now everything else falls in between and is consistent with the order rule. Okay, this is the second best prospect. This is the third best prospect. This is the fourth best prospect, and this is the fifth best prospect. The order according to the preference rule matches up nicely with the order rule. That is the second rule in the 5 rules of actional thought. Okay, so preference probabilities is one set of measure to put some values to each prospect. In this chapter, we're going to look at another set of measure for prospect values, money. Okay, so here is the question. Kim, what is an outdoor party in the sunshine worth to you in terms of dollars? What is the outdoor party in the rain worth to you in terms of dollars? We're asking Kim to put a dollar value to each of the 6 prospects. Okay, so we do know that Kim has a rank order of the 6 prospects, so that we can either start with the best one or we can start with the worst one. Okay, here we can start with the worst one. Kim, what is your dollar value for an outdoor party in the rain? Okay, Kim says, well, I'm essentially indifferent between having the outdoor party in the rain versus not having the outdoor party in the rain, if these two are my 2 options. Okay, that means Kim puts a $0 value to an outdoor party in the rain. Okay, so whenever someone is indifferent between having something and not having something, that something essentially means $0 value to that person. Okay, so that's how we know Kim's willingness to pay or Kim's value of the prospect outdoor party in the rain is $0. Okay, and then just like what we did before, we can put this dollar measure at the end of the decision tree rather than the preference probability. Okay, here we put 0. And then what we need to do is to do this for all the prospects. Okay, and then Kim indicated that her value of an outdoor party in the sun is $100. The way to think about this is Kim is equally happy between having an outdoor party in the sun and receiving $100. Okay, the indifferent dollar amount is what we are looking for. If you offer Kim $99 versus an outdoor party in the sun, Kim would choose the outdoor party in the sun. If you offer Kim $101 and the outdoor party in the sun, Kim would choose the $101. $100 is where she switches. Okay, she's equally happy between this dollar amount, between receiving this dollar amount with having an outdoor party in the sun. Okay, and then she told us her dollar value for a porch party in the sun is $90. For a porch party in the rain is $20, and for indoor party in the sun is $40. For indoor party in the rain is $50. Okay, again, these are dollar values rather than preference probabilities. This is another set of measure that we can ask Kim to give us. Okay, You can also read the textbook section 2.1 of chapter 10 for more explanations on these dollar values. Okay. So what I want to point out to you is that if you rank the 6 prospects in terms of their dollar values, the rank order should be the same with that from the second rule of 5 rules of auctional thoughts, the order rule. See? Outdoor party in the sun is the best, so that has the highest dollar value. Porch party in the sun is the second best, that has the second highest dollar value over here. IR is the third best, and it does have the third highest value among the 6, so on and so forth. Kim's dollar values should be consistent with her order of all the prospects in the order rule. And another important clarification is that these dollar values are not the cost of the party. Okay, it doesn't mean that it cost Kim $100 to hold an outdoor party in the sun. This is a dollar measure of the pleasureness that an outdoor party in the sun brings to Kim. Okay, this is the pleasureness or the plus side rather than the cost side, which is the the minus side. Okay. So why are we using money to measure the 6 prospects for Kim, or why are economists so fixated on using money to measure everything? Okay, this is detailed in the textbook on page 216 to 217. You can read it by yourself, but here is a list of the gists. Okay, the first thing is to recognize that economists are pretty used to use money to measure everything, but this can be off-putting to others who are not in the profession. For example, when economists are trying to put a money value to a person's life, the other persons might fiercely object to the idea that how can you put a price on a person's life? Something like that. That being said, there are some values or there are some good things about using money, because money is familiar, money is fungible, money is divisible, money is alienable, and money is simple. Okay. Now we have 2 sets of measures on the 6 prospects in the party problem. As you can imagine, we can sort of match up the 2 sets of measures like this. Okay, we have figured out that Kim puts $100 on this prospect. Also, Kim has a preference probability of 1 for this prospect, and then $90 for the second best prospect, and her preference probability is 0.95. And then you have all these corresponding relationships. Okay, the dollar value, this set of measure are dollar values. This set of measure are preference probabilities. So now we have this equivalence rule that tells us that when $100 has 1 preference probability, $90 is equivalent to 95% of preference probability, and so on and so forth. And both measures are consistent with the order rankings from the order rule, no matter if you use preference probability to rank these 6 prospects, or if you use the dollar values to rank these 6 prospects. Okay. What I want to do now is to introduce the concept of risk aversion. Okay, so now instead of putting these preference probabilities here, I want to recover the binary deal behind those preference probabilities. Okay, so this preference probability corresponds to this binary deal. Prospect PS is equivalent to this binary deal between the best and the worst. Okay. Again, remember what is best? That is OS. What is the worst? That is OR. So we can replace this B with OS or with the dollar value that corresponds to OS, correct? So there we go. And then we can replace this W, the worst prospect, with either OR or its equivalent dollar value. So we can replace this W with 0. There we go. And we can do that for all these all these 6 binary deals. Okay. We know that an outdoor party in the sun is equivalent to this binary deal between $100 and $0. A porch party in the sun is equivalent to this binary deal, 95% of chance of receiving $100 and 5% of chance to receive $0. IR is equivalent to this binary deal between $100 and 0, so on and so forth. Okay. Now these 6 prospects are sort of the bridge between the certain dollar amount and a binary deal between 2 dollar amounts with some uncertainties. Now we can get rid of this bridge and then put this $100 as the equivalent dollar for this binary deal. $90 is equivalent to PS, which is further equivalent to this deal. So essentially we can just get rid of this bridge in the middle, which are the 6 prospects, and then put the 2 measures together. Okay. Examining the 2 sides of the equal signs, we can tell that Kim is a risk-averse person. First, I'll give a definition. A risk-averse person values an uncertain deal below its expected value. Now first, let's look at what is an expected value of a binary deal. As you have learned from the statistical classes, you can calculate the expected value by multiplying the prices with its corresponding probability and then add them up. For example, for this binary deal, the expected value is this price, $100, multiplied by its probability, 0.67, plus this price, which is $0, multiplied by its probability, which is 0.33, and then you add them up. That gives you $67. Now, this expected value is what Kim would get on average if this binary deal is played a lot of times by her. For example, if Kim plays this binary deal 100 times, then statistically speaking, she'll get $100 in the 67 times she plays, and $0 in the 33 times that she plays, which makes the average payoff she receives each time equal to $67. But note, despite that on average, Kim receives $67 if she plays the binary deal a lot of times, the actual payoff that she receives each time is either $100 or $0, and she is uncertain which one it is. Now, instead, imagine Kim has 2 options. Option 1 is to play this binary deal, which gives her the uncertainty between $100 and $0. While option 2 gives her $67 for sure. Kim would choose option 2 since it has no uncertainty in terms of how much she can get if she chooses this amount. As a matter of fact, if you reduces the option 2 to $66, Kim would still choose the $66 for sure. She's willing to sacrifice $1 to avoid the uncertainty in the binary deal. The same goes true if option 2 further reduces to $64, $65, until it reaches $51. Now, if option 2 is $50, Kim is indifferent between these 2 options. Now, if further option 2 reduces to $49 or lower, Kim would choose this binary deal instead. This $50 is where she switches, and it is called certainty equivalent. Now, if you look at this term, the first word, certainty, means that this $50 is received for certain. The second term, equivalence, means the dollar amount is equivalent to the binary deal, in the sense that Kim is indifferent between these two options. Please understand that certainty equivalent is a subjective measure of Kim's value of this binary deal, which is unique to Kim. So this $50 is unique to Kim. While the expected value is an objective measure of average payoff that is governed by statistic laws, which is the same for everyone who is facing this binary deal. Okay? Now the fact that Kim is willing to sacrifice as much as $17 to remove the uncertainty in the binary deal, that makes her a risk-averse person. If someone else is willing to sacrifice even just $1 from $67 to avoid the uncertainty, that person is also a risk-averse person. That is how you can understand that when certainty equivalent is below the expected value, a person is risk-averse. And as you can see, Kim always have a lower subjective value than the objective value of the uncertainty deal. That makes her risk-averse. Okay? And for a person, we assume that it is either always the case that the certainty equivalent is below the expected value or equal to or higher to. So for a person, it usually is not the case where the certainty equivalent is higher than expected value for some cases and then lower than the expected values for the other cases. That is to say, a person is always risk-averse, or he or she is always risk-neutral, or he or she is always risk-loving. Okay, we don't have a person who switches from being risk-averse to being risk-loving across different scenarios. So that is usually what we assume when we look at people's risk attitudes. Okay? And again, risk-averse, risk-neutral, risk-loving, we call these properties a person's risk attitude. Okay? Now, this is what I just said again in texts. So here is Tim, whose certainty equivalent is exactly equal to the expected value. That makes Tim a risk-neutral person. Okay? And Sam here has a higher certainty equivalent than the expected value for all these binary deals. Okay? For this higher than 32, that makes Sam a risk-loving or risk-preferring person. Okay. And what is risk-averse? What we want to do is to graph a U-curve for Kim. We can also do this for Tim, who is risk-neutral, and also for Sam, who is risk-loving. We'll do that after we look at Kim's U-curve and then do some analysis based on Kim's U-curve. So we're going back to Tim and Sam later after we're done with Kim. Okay? So a U-curve is essentially a coordinated space where you put all these dollar values, all these uncertainty equivalents onto the horizontal axis. And then you put all these preference probabilities, that is, all the probabilities that are associated with the higher prices, onto the vertical axis over here. So as you can see, the vertical axis is ranged between 0 and 1, and the horizontal axis is ranged between the lowest price in the binary deal and the highest price in the binary deal. Okay? So this allows us to put all of these 6 deals onto this space because we included all the ranges in terms of dollar values, and then we included all the ranges in terms of preference probabilities. So we started with drawing this binary deal onto Kim's U-curve. Again, these are Kim's equivalence relationships of binary deals on the right-hand side. Okay, so what we're drawing only represents Kim's preference probabilities and equivalent preferences. So first, this $100 is what goes onto the horizontal axis, and this number 1, which is 100% preference probability, goes to the vertical axis. So that gives us this point over here. And again, if you go left, you can read it's 1. If you go down, you can read it's $100. Okay, so that's how we're representing Kim's equivalence relationship top here with a dot, with a point on the coordinated space. Okay, and then we can go on drawing this second point to represent this second equivalence relationship. Again, $90, that's how we find it over here. We draw a line, an auxiliary line going upward, and then 95% goes here. So we draw a horizontal line over here. And the point where these two lines meet is the point we will use to represent this relationship. Okay? And then we do that for this one. That is this point. Going down, we have $50. Going left, we have 0.67. Okay, and this point going down, we have $40, and going left, we have 57%, 0.57. Again, this one going down, we have $20, which is something over here, and going left, we have 0.32, which is the preference probability of this $20 in the binary deal between $100 and $0. And the last one is this one. Okay, $0 is equivalent to receiving $0 with 100% of the chance. Okay, so this is what Kim told us. Her preference relationship between the 6 binary deals and some certain amount of dollar amounts. So we can ask her a couple more, and then we can draw these dots, and then after we draw plenty of dots, we will be able to connect all the dots, all the points with a smooth line. That gives us Kim's U-curve. If you think about this curve represents infinitely many points. So from this U-curve, there are a lot of information that you can tell in terms of Kim's risk preference. For example, you can tell, if you're giving Kim a binary deal between 60% of receiving $100 and 40% of receiving $0, then you would go to the 60% point, 0.6. You would go left to the horizontal, you would go left horizontally to the U-curve, and then you will go down. And then that tells you how much that binary deal is worth to Kim. Okay? So Kim's U-curve contains a lot of information that is helpful to make decisions for her in situations where she faces uncertainty. I want to emphasize that a dot on the U-curve represents a binary relationship. See, the blue dot on the U-curve represents the binary relationship that is circled with the blue dashed line on the right. That $50 is equivalent to a binary deal where 67% of the chance receiving $100 and 33% chance of receiving $0. I also want to remind you guys that the three statements here are the same. They all refer to the same binary relationship as circled by the blue dashed line on the right-hand side of the screen. Okay, it's just different ways to represent or to interpret that binary relationship. You should be comfortable with all three statements in your exercises and in your exams.
Using this U-curve, we can answer a lot of questions, starting with simple questions like this. So you can read from Kim's U-curve. What is Kim's U value of $100? The way to do that is to find the $100 and go vertically up to a point on the U-curve, then go horizontally left to find the value on the preference probability axis. Okay? And then the second question is, what is Kim's U value of $0? Again, we're asking a U value. We're looking for a U value of some amount of dollars. So what you need to do is to find that dollar first. Then, well, that point is exactly on this curve, and the vertical axis reads 0. So that gives us the answer. Kim's U value of $0 is 0. Now, how about Kim's U value of $50? Then you would go find $50 over here, draw a vertical line up to the U-curve, and then find a point there, and then go left to read the value on the U-curve, on the vertical axis, which is somewhat 0.67. Excuse me. Okay. So the first three questions are questions where you're given a dollar amount and you're asked to find the U value of it. And the last question is on the reverse direction. You're given a U value, and then you're asked to find the dollar amount that gives Kim that U value. Okay? Since you're given the U value, then what you need to do is to find that U value on the vertical axis over here, then go horizontally to the U-curve, find the intersecting point, and then go down to read the dollar amount that gives Kim a U value of 0.5, which is somewhat $36 or so. So if you're given an exercise like this, unless these lines are given and numbers are given, if you're reading it by guessing, then the range is probably fine. So 36 is okay here, 35 is okay here, $37 is also okay here as the correct answer. But if in the homework or in the quizzes or exams, if these lines and these coordinates are given, then you should read it accurately. Okay? So the next part is to use U value to a U-curve to value uncertain deals for a person. Okay? Again, to begin this part of lecture, we want to clarify that these three terms are equivalent to each other. They are referring to the same dollar amount that correspond to an uncertain deal. Okay? The value of an uncertain deal is equivalent to the certainty equivalent of the uncertain deal, which is also equal to the willingness to pay or willingness to accept for that uncertain deal. Okay? So the value, certainty equivalent, willingness to pay, willingness to accept, these three terms, the three technical terms, refer to the same thing. So, okay, over here, what we're trying to do, again, this is Kim's U-curve. Okay, if you can see the red dot, over here, this is Kim's U-curve that we just draw from the previous part of lecture. This is given to you by Kim. Okay, Kim gives this U-curve to you to represent her risk preference. And now she's facing an uncertain deal like this. Okay, so suppose Kim is facing an uncertain deal with a 50-50% chance of receiving $100 and $0. Now the question is, what is the maximum price Kim is willing to pay to play this deal? Which is equivalent to ask, what is the certainty equivalent of this binary deal to Kim? Which is also equivalent to ask, what is Kim's value of this uncertain deal? Again, the three terms that we just saw, they are referring to the same thing, which is represented by this red question mark. Okay. So that's the first thing. We are clear of what we're looking for. We're looking for a dollar amount that makes Kim equivalent between receiving that dollar amount for sure versus receiving this binary deal of equal chances of winning $100 and $0. So in order to find this dollar value, what we need to do is to first find the U value of these two prizes. Okay, the way to do that is something that we just learned, right? First, we find the dollar amount, then we go up to the U curve, then we go left to read the U value on the vertical axis. So to find the U value of $100, you find that $100 point on the horizontal axis. Okay, go up, find the point, go left, read the value, which is 1. Okay, because $100 is the maximum amount on the horizontal axis. So for that maximum amount, the U value is always 1. Okay, $0 again, find $0 over here and read it. That gives us a U value of 0. Again, $0 is the lowest amount that is on the horizontal axis. So the U value for that lowest amount is usually 0. Okay, so that's what I did over here. In order to help me visualize the process and mark things clearly, I have put the U values to the right of the prizes. Okay, that's what you can do to help you remember what the U values are. And that's the first step down. Okay, the first step is always finding the U values of the prizes of the uncertain deal. And then the next step is to find the E value of the U value of the prizes. Okay, the way to do that is to use the probability of one prize times the U value of that prize plus the probability of the second prize times the U value of that prize. So that is how we read this formula over here. Again, 0.5 comes from here. 50% of receiving $100. 0.5 times the U value of $100. 50% of chance receiving $0. 50% of the chance times the U value of $0. Okay, and after you plug in this U of $100 is 1, that is what we find in step 1. The U value of 0 is 0, that is what we find from step 1 as well. And then you calculate, and then the E value of the U value of this uncertain deal is 0.5. So we mark 0.5 over here. Okay, so the U value of the deal is referring to this E value of the U value of the prices. Okay, so these two ways of saying things are both correct. You can say that the U value of this uncertain deal is 0.5, or the expected utility of the deal is 0.5. You can use this U value and expected utility term interchangeably. Both of these are fine. Okay. Now the last step is to find, well, what dollar amount gives Kim the U value of the deal. Okay, so in order to do that, what we need to do is to find the dollar amount that gives Kim a U value of 0.5. So again, this is like the last question, question 4, before we start this part of lecture. You're given a U value, now you're asked to find the dollar amount that is equivalent to that U value. The way to do that is to find 0.5 on the vertical axis first, okay? Then go right to find the intersecting point on the U curve. Then go down to read that dollar amount on the horizontal axis. Okay. So that dollar amount over here, what I read is $34. You can do $35, you can do $33, as long as it is in the ballpark, that is fine. So now we have figured out that $34 is giving Kim $34 is equivalent to giving Kim a binary deal between $100 and $0 with equal chances. Okay, and again, you can interpret this binary relationship in a lot of ways. For example, you can say that Kim's certainty equivalent is $34 for this binary deal, or Kim's willingness to pay for this uncertain deal is $34, or Kim's value of this uncertain deal is $34. Okay. If we take a moment to look at this equivalent relationship, we can see that whenever we have an equal sign over here, whatever is on the two sides, they should always have the same U value, correct? We have figured out $34 U value is 0.5, and the U value of this binary deal is also 0.5. So whenever we have an equal sign, no matter if it is connecting between a certain amount of dollars and the binary deal, or later, if you see an equal sign with an uncertain deal over here, with another uncertain deal over here, it means that the two sides have the same U values. Okay, in this class, that equal sign represents the same U values. Again, the same U values is essentially saying that that person is equivalent or is indifferent between what's on the left and what is on the right. Okay, another thing to do that we can tell is that, again, Kim is risk averse because the expected value of this uncertain deal is $50 versus Kim's certainty equivalent is only $34. $34 is below the expected value, which concludes that Kim is risk averse. Okay. And also all these statements are correct. So we can say that Kim's certainty equivalent of the binary deal is $34. Kim values this uncertain deal at $34. The binary deal is worth $34 to Kim. Kim's willingness to pay for the binary deal is $34. Kim's preference probability for $34 in the binary deal between $100 and $0 is 0.5, or Kim is indifferent between receiving this amount for sure versus receiving this uncertain deal. Okay, all these 6 statements are correct, and in your homeworks or in your quizzes or in your exams, some of these statements will be shown as the options in those multi-option questions. So all this you should be able to tell from some equivalence relationships over here. Okay, and here is another example that we can do. So sort of figure out what is Kim's certainty equivalent between the binary deal like this, with a 40% of chance of receiving $90 and 60% of the chance receiving their $30. Again, following the same 3 steps as we did before. The first step is to find the U values of the prizes. Okay, so for a $90 prize, the U value is find $90 over here, go up, go left, which is, and then for the other one, which is 0.95, and for the $30, go here, find the $30, go up, go left, and the U value is 0.4. So that is the first step. Figure out Kim's U values of the 2 prizes involved in this uncertain deal. The second step is to find the U value of this uncertain deal, which is 0.4, which is the probability of receiving $90, times the U value of $90 plus 0.6, times the U value of the other price, which is equal to 0.4 times 0.95. This we figured out in step 1, plus 0.6 times 0.4. 0.4 is what we figured out in step 1. This should be 0.4. Okay. And then the last step is to figure out what kind of dollar amount gives Kim the same U value of the lottery or of the binary deal. Okay. The way to do that is to go to 0.65. Okay. And then go right to the curve, then go down to read go right to the U curve, go down and read the dollar amount, which is $48. Okay. Again, the $48 is figured out because $48 gives Kim the same U value as the binary deal gives Kim the same U value, which is both equal to 0.65. Okay. U value is really telling us a lot about Kim's preference between dollar amounts and binary deals, or even deals with more than 2 prizes. Okay. Here is some sort of rule of thumb or equivalent statements. If Kim is indifferent between 2 deals, that means Kim's U values for the 2 deals are the same. That it also means Kim's certainty equivalents for the 2 deals are the same. Okay, so 2 deals give someone the same U values. That means someone is indifferent between the 2 deals. Or that also tells us someone has the same certainty equivalent between the 2 deals. And this is like just another direction. If Kim prefers one deal to the other, that means Kim has a higher U value for the deal that is preferred. Or that also means Kim has a higher certainty equivalent for the preferred deal. Okay, and these have to calculate a U value of a deal, which is just what we saw before, but with expanded capacities to include more prizes and more probabilities. The probability of prize 1 times the U value of the first prize, plus the probability of receiving x2 times the U value of x2. You can do plus the probability of receiving x3 times the U value of x3 if you have a third prize, calling it x3. That is the U value. You can see that in the calculation of a deal, there is this U function which represents the U curve. When we calculate the expected value of an uncertain deal, there's no such thing as the U value. Okay? Just use the probability of receiving x1 times x1 plus the probability of receiving x2 times x2, and then that gives you the expected value. Doesn't involve any U's here, which means this is objective, which is the same for everyone. So we can use this to compare 2 uncertain deals for Kim. So if we were to compare this deal A between $100 and $0 versus this uncertain deal between $90 and $10, we can compare the U value of this deal and the U value of this deal. Whichever deal has a higher U value, that is the preferred deal. Okay. We can also compare the certainty equivalent of the deal A and the certainty equivalent of the deal B. Whichever deal has a higher certainty equivalent, that deal is preferred. Okay. So to do that, we can figure out the U value of deal A. Actually, we have figured this out as the first example when we are trying to find the certainty equivalent of it. Okay. 0.5 times U value of $100 plus 0.5 times U value of $0. So the U value of deal A is 0.5. And we have figured out that the certain equivalent of this deal A is $34. The way to do that is to find 0.5 and then go down, which is $34. And we do the same for deal B. Okay, the U value of deal B is the probability of receiving $90 times the U value of $90 plus 0.5, which is the probability of receiving $10 times the U value of $10. Okay, that gives us a 0.545, which is equivalent to a certain amount of dollars, which is $42. Okay. Now the question is, which one of these two deals does Kim prefer? Okay, you can answer that by comparing the U values. Since deal A has a lower U value, which is 0.5, than deal B, which has a U value of 0.545, we conclude that Kim would prefer deal B to deal A. Okay, so if you offer these two deals to Kim, she would choose deal B over deal A. You can also get that conclusion by comparing the two uncertainty equivalents. Okay, deal A is equivalent to $34 for sure. Deal B is equivalent to $42 for sure. That means Kim prefers deal B to deal A, which is the same conclusion as when you compare this U value of deal B to U value of deal A. These two are the same. These two methods will lead to the same conclusion, I should say. Okay. Do we have any questions about comparing two binary deals? Okay. So as you can see, you can compare this 1, 2, 3, 4, 5 deals actually using the same method. So I'll leave you guys to do this exercise after this class. The way to do that is to figure out the U value of this deal, the U value of this deal, the U value of this deal, and compare all the U values of the 5 deals. Then you can rank these 5 deals for Kim in terms of what is the best deal and what is the worst deal. Okay, the best deal has the highest U value. The worst deal has the lowest U value. Also, the highest deal has the highest certainty equivalent, and the worst deal has the lowest certainty equivalent. No matter which way you use, you will lead to the same ranking of the 5 deals shown on this slide. Okay. The reason that we care about certainty equivalence of deals, despite of having all the information in the U values when we try to compare them, is that sometimes we do need to figure out the certainty equivalent in order to calculate the value of perfect information, which is the last topic that we will cover in this chapter, to be covered later, way later. Okay. So what we want to do now is to apply what we learned so far to the problem of Kim's party. Okay. So this is Kim's party problem, if you recall, that she has 3 options: outdoor, porch, or indoors in terms of party locations. And she has already assigned probabilities to the weather, to the 2 possibilities of the weather according to rule number 1 of the 5 rules of actional thought. And also, Kim has figured out what is the equivalent dollar amount to each party scenario. Okay, Kim values an outdoor party in the sunshine at $100. Kim values an outdoor party in the rain at $0. Kim values a porch party in the sun as $90. And Kim values a porch party in the rain at $20. Kim values an indoor party in the sun at $40, and she values an indoor party in the rain at $50. So what we did here is essentially change the 6 prospects into their equivalent dollar amounts. Okay? These dollar amounts represent Kim's preference across the 60 across the 6 prospects. And if you compare these dollar values with Kim's preference ordering of the 6 prospects from the order rule of the 5 rules of actional thought, you would figure out that they are in the same rank order. She prefers outdoor party in the sunshine the most, outdoor party in the rain the least, and everything else is in between. And you can tell that Kim prefers a porch party in the sun to an indoor party in the rain, since $90 is greater than $50. All these are the same orders as we did when we used the 5 rules of actional thought to solve Kim's party problem. Okay, the next question, again, the ultimate question we want to answer is, how would Kim choose? Would outdoor be the best option, or porch be the best option, or indoor to be the best option? In order to do that, we need to compare this binary deal with this binary deal and with this binary deal, correct? Because an outdoor party, to choose to have the party in the outdoor is leading to a binary deal of receiving 40% chance of $100 and 60% of the chance of receiving $0. So this is the binary deal that Kim faces if she chooses to hold the party outdoors. And this is the uncertain deal that Kim faces if she chooses to hold the party in the porch. And this is the binary deal that Kim faces if she chooses to hold the party indoors. Okay, so the comparison across the 3 options comes down to the comparison of the binary deals, which we can use what we learned just now to do. So we would need to find the U value of this binary deal, find the U value of this binary deal, and then find the U value of this binary deal. Whichever binary deal has the highest U value, then that option is most preferred. Okay, so to do that, the first step is to find the U values of the prices. Okay, so that's what we do. Again, the 0.95 is found on the U curve. $90, go over here, go up, go left. That gives us 0.95. Okay, $20, go here, go up, go left. That gives us a 0.32. So all these U values are read from the U curve. Okay, and then to find the U values of the binary deals, we just need to multiply the U values with its corresponding probability and then add them up. So the U value of this outdoor deal is 0.4 times 1 plus 0.6 times 0, which is 0.4. A U value of 0.4, go here, go right, go down. This gives us, well, $26. So this outdoor party has a U value of 0.4, which is equivalent to receiving $26 for sure. Okay. So this $26 is the certainty equivalent of this binary deal after choosing outdoors. Okay. Let's do that for porch. So I've already calculated the U value of porch, which is 0.4 times 0.95 plus 0.6 times 0.32. So the U value of a porch party is equal to 0.57. Now the question is, what is the certainty equivalent of this porch party? So to figure that out, you go to 0.57. Over here, go right to the U curve, go down to the axis, which reads at $40. So a porch party is equivalent to $40. Okay, let's do that for indoors. 0.4 times 0.57 plus 0.6 times 0.67. That gives us a U value of 0.63 for an indoor party. Okay. To find the certainty equivalent, we find this 0.63 on the vertical axis, go left, go right to the U curve, and then go down to read the certainty equivalent, which is $46 something. Okay, so here, $46 is the certainty equivalent of the indoor party. So we have some U values here. We have some certainty equivalents here. So to differentiate between the certainty equivalents and the U values, well, we just enclose the certainty equivalents with rectangles to tell us that this is representing a dollar amount. Okay. Well, the dollar signs does that too, but the textbook decided to make it extra clear by enclosing the dollar amount, the certainty equivalent, with a rectangle. Okay. So that's why we see a rectangle over here. Now going back to the choice problem, where should Kim have the party? So again, like I said, you can do it in two ways. Well, outdoor party has a U value of 0.4. Porch party has a U value of 0.57. Indoor party has a U value of 0.63. So of course, Kim should choose indoors since it has the highest U value. Or you can use the other method. Outdoor party is equivalent to $26 for sure. Porch party is equivalent to $40 for sure. Indoor party is equivalent to $46 for sure, since indoor party has the highest certainty equivalent, which means indoor party is the most preferred. Actually, you can tell that porch party is the second preferred option, and outdoor party is the least preferred option. Okay, that makes sense though. Like Kim is risk averse. Outdoor party gives her some quite large ranges, like either you're in the best scenario or you're in the worst scenario, versus this option is obviously safer. That gives Kim somewhat two scenarios that are close to each other, not so much different. So Kim would pick the indoor party, indoor location for her party because that option has the highest certainty equivalent. Also because it has the highest U value. Okay. No matter which one you use, it is the same conclusion. It is also the same conclusion as we get at from applying the 5 rules of actional thought. Okay, so again, no matter which method you use, you would reach to the same conclusion.
You might want to ask the question that,
why would you not just compare the U values? It seems redundant to go through the trouble finding the certainty equivalents when you can just compare the values. That is an excellent question. Again, finding the U values is very much enough to answer this current question, which option to choose. However, in later questions, when we are trying to figure out the value of informations, these certainty equivalents are absolutely needed. Okay, so we're just finding this sort of as a byproduct of the comparison because we're going to use that later. Not necessarily, we do not necessarily need these certainty equivalents to compare the 3 options, but we absolutely need that in order to figure out what is the value of perfect information for Kim in this situation. Okay. Well, actually, someone asked before, in the exam, will we be asked to rate U value according to the U curve? The answer is probably. Okay. However, you do not need to be super precise in the rating. As long as it is in the sort of ballpark, then that is fine. Okay. Well, again, like I said, the U curve contains a lot of information of a person in terms of her preference when she's facing uncertainties or risks. if we are given a yield curve of a person, then we can make a lot of decisions for her as her agent that represents the best interest of Kim.